Hello. Let us evaluate this interesting limit. The limit as x goes to infinity of x to the power exponential of negative x. We all know that the limit as x goes to infinity of exponential of negative x is 0. So, the initial evaluation of this limit will give infinity to the power 0. Which is an indeterminate form. This means that we should use the L'Hospital rule to address this issue. As a matter of fact, the main function, x to the power exponential of negative x, is an exponential function. So we need to use a logarithmic transformation to simplify this problem. So, we set y equals x to the power exponential of negative x. Then, by taking the logarithm of both sides of the equation, we get logarithm of y equals to exponential of negative x times logarithm of x. Here we are using the inverse properties of logarithm of and exponential functions. Now, we will be studying the limit of logarithm of y as x goes to infinity. Please do not forget to like the video and subscribe to our channel. Thanks. The new problem we should study is the limit as x goes to infinity of logarithm of y, which is equal to the limit as x goes to infinity of exponential of negative x times logarithm of x. However, we know that the limit of log x as x goes to infinity is infinity. This is still an indeterminate form of the type 0 times infinity. In fact, in order to solve this type of indeterminate form, we need to use the L'Hospital rule. However, this rule primarily applies to the case of 0 over 0, or infinity over infinity. So, the first thing we have to do is to transform the product exponential of negative x times logarithm of x into a fraction. For this, we have to replace the exponential of negative x by its equivalent form, 1 over exponential of x. The new expression of the limit is limit as x goes to infinity of logarithm of x over exponential of x. But if we evaluate the limit as x goes to infinity of logarithm of x over exponential of x, we will get infinity over infinity. By the L'Hospital rule, this limit is equal to the limit as x goes to infinity of the derivative of logarithm of x over the derivative of exponential of x, which is equal to the limit as x goes to infinity of 1 over x over exponential of x. Because the derivative of logarithm of x is 1 over x, and the derivative of e of x is just e of x. By simplifying this fraction, we see that the limit is equal to the limit as x goes to infinity of 1 over the product x times e of x. We all know that as x goes to infinity, x times e of x goes to infinity. So our limit is 1 over infinity, which is 0. In sum, the limit as x goes to infinity of logarithm of y is 0. Recall that the original expression, x to the power of exponential of negative x is equal to exponential of y. This is because logarithm of y was defined early as logarithm of the quantity, x to the power of exponential of negative x. Here we are using the inverse properties of e of x and logarithm of x. So, the limit as x goes to infinity of x to the power of exponential of negative x is equal to the limit as x goes to infinity of e of logarithm of y, which is equal to the exponential of the limit as x goes to infinity of logarithm of y, which is e of 0. And this is equal to 1. Finally, the limit of our expression x to the power of exponential of negative x when x goes to infinity is 1. Thanks for watching the video. Please like and subscribe to our channel. Thanks.